Welcome to Assistive Robotics Live. Today we have a very special guest, somebody who's one of the world's top experts in building robots. And he's going to show us how building a robot might be easier than you think. Two people who've never built robots before in their whole life to turn ordinary stuffed animals into animatronic stuffed animals. Stay tuned.
You know, sometimes it gets lonely in here. I wish we had a cute little robot to wave to us when we came inside a building.
How are we gonna build that? I'm just a public relations major and you're just a journalist major.
Well, you can't, because anyone can build. I'm a robot ninja master, and I can help you build anything you can dream of.
I kind of want to build a little pet that waves to us when we come in the lab. Can you help us make that?
Absolutely. Each step you complete will bring you closer to the goal of becoming your own robot ninja master. But first, you will need supplies. To become ninja masters, I've prepared a series of challenges for you. When you complete these, you will have made your own robot dinosaur pet, and you will become beginner robot ninja masters. Here are these challenges I leave with you. Best of luck. If you need help at any point on your journey, press this magical emergency stop button, and I will appear to help you with anything you might need. Good luck.
Well, we got the first step. Are you ready?
So we're just gonna ignore the fact that Ninja just came and gave us instructions.
Yep, strange things happen all the time. Let's go. So for the first challenge, we have to assemble the servo. We have to put the horn of the servo on and secure it with a small black screw. It should look like this picture when we're finished. So... Where? It's this. Yeah, okay, I think it's this. Oh my god, it's hokey colors.
What's to do with my thing?
Ninja, we need a screwdriver. No. Say no. We could have really just used the same hat, I just realized.
Don't we need both parts? Don't do this at home without an adult supervision. I love hot glue.
Challenge 1 complete. Anyways, challenge 2, install Arduino. Download and install the Arduino software from here. We have to go get our laptop. You are using an Arduino Uno R3 microcontroller. Okay, so I'm gonna guess this is the microcontroller. Is this a microcontroller?
So a microcontroller is a little computer, one that's specially designed to read in signals such as voltages varying over time or special patterns of voltage from other chips. It converts these signals to binary numbers so it can do math with them. A microcontroller can also output signals to other things, such as chips or LEDs.
Step 2, done. Oh, a piece of cake. So challenge 3, plug servo into Arduino. Plug the servo into your Arduino as well as shown in the picture. You will need to use some extra wires to make sure everything is connected properly. Okay. So plug in the servo, which is this. We need more wires.
Robot Ninja Master forgot to include the extra wires in the kit. Even Robot Ninja Masters make mistakes sometimes.
Yay, thank you. Okay, the yellow servo wire, which is this one, will be plugged into the digital pin 9.
Wait, do I plug it into here?
Oh! G and B.
It's right here. Okay, now let's go. And we got the yellow one.
Oh.
Look, the yellow one. Yeah, bro. Okay. Complete.
Challenge.
Yeah.
Challenge 4, make the servo move. Test out your servo, download sleep example code from this website, and then try to run it. There's some coding, but we're gonna copy it from this website.
In our sweep example code, first we load libraries to tell the microcontroller we're dealing with a servo. We then make a variable which will hold the servo's position. This can go from 0 to 180 degrees. We then tell the microcontroller that we're connecting the servo to digital pin 9. Next, we do a loop. We tell the servo to go from 0 degrees to 180 degrees, and then back to 0 again. Since this is a loop, it will do this back and forth forever.
After some time, we have finished step 4. Okay, challenge number 5. Twist the wire ends to the wire that will be plugged into the distance sensor. Match the wire colors. Put electrical tape around them when they are finished being twisted.
Not yours already done. That's not fair.
The ninja gave me the completed one.
You know what?
Now it's twisted, and then you want your electrical tape. Snip, snip. Okay, you're gonna put the electrical tape, and then you're gonna...
Got it. I got it. I did it. I did it. I did it. It shouldn't have been that hard, but I did it. Shanti, the science girl. Shanti,
You build it, you got it.
the science girl. Shanti, Shanti, Shanti.
Plug.
And
Plugged in.
yeah.
Have your cords be like this.
Girl, my cords are doing the loop-de-loop and pull. You know what SpongeBob would say.
So this was cool and all, but I don't understand how this distance sensor works. Ninja, can you help explain it to us?
I can definitely tell you how a sensor works.
The distance sensor has 2 circles. One of these is an infrared LED, which shoots out invisible light. The other one is a lens on top of a detector. If there's an object in the way, the light reflects off the object, goes through the lens and onto the detector. This creates a voltage. If the object is close by, the light shines onto a different spot on the detector, which creates a different voltage. If you do this for a bunch of different object distances, you get a curve which looks like this. With this, we can tell how far away an object is based on the voltage coming out of the sensor.
Step 5 stuff. Challenge 6. Plug in the distance sensor. Add your distance sensor into the circuit as shown here.
Let's do black. Black seems simpler. Can we put black into the other G and D symbol?
Yellow sensor wire and analog
A0.
0.
Okay, I see what it's talking about, but like, we're supposed to put it here. Ta-da! Challenge 6
Complete.
We're already halfway there. Have a robot. Next.
Challenge 7. Make them work together. Make your distance sensor control your servo by copying the knob example from here and programming it to the microcontroller. Okay. You know, anyone can build, but anyone who builds needs to have patience. It's moving up there. And you just copied it wherever?
I copied the knob.
Did yours work?
Hey, you gotta delete the other one.
Mine said there's a problem.
Did you copy the knob one?
Yeah. Oh, no, it still said there's a problem. What'd you do?
I did. I just delete everything like he told me. Copy that one and then paste it.
Okay, copy.
I did it right.
I think yours is correct.
Yay!
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
My code's not working.
Uh-oh. All right, well, let me come see what we can do.
In our knob example code, a couple of lines are exactly the same as what they were in the sweep example. Here we have 2 variables. Originally, this was written to use a potentiometer, which is a variable resistor. If you rotate the potentiometer, it creates a time-varying voltage at the output. But in our case, we're going to be using a distance sensor to create a time-varying voltage. This will be read into the microcontroller through analog pin A0. The voltage created by the distance sensor varies from 0 to about 3 volts depending on the distance to the object. When we read it into the microcontroller, it's converted to an integer between 0 and 1023. We then need to map this to 0 to 180 to send a signal to the servo, which is done with the last bit of code.
Step 7, complete. Now for challenge 8, modify the code. Next, combine the knob and sweep examples so the dyno moves back and forth. When you're closer, then some distance. Start with the knob code.
Our combined code is very similar to the knob code, except for a few differences. We have a new variable holding the servo position. Next, if the value is greater than 200, which corresponds to the object being pretty close, then it'll cause the servo to go back and forth. And that's it.
Like up here.
Yeah, that's where it says next to this. See?
Oh, like that.
Yeah, roughly. It doesn't matter where you put it, I guess.
Yeah, Mike was saying unexpected. Wait, maybe the tools. Port. Okay, is that the right port? We need help with the code.
Oh, I screwed up. I know what it is. Did you put the greater than sign?
Yeah, it's still not. It still says no. Yay!
I fixed it. Am I becoming a master? It is done.
Make sure to upload your codes.
I don't know how I missed a whole chunk.
Okay. Make sure your code is working as you want. Feel free to. No, I'm not modifying. If it stops working, you can always go back to the version that was working correctly before. Okay, cool.
Oh my god.
Well,
Surgery!
it's time to cut him open.
Are you ready, Daisy? We're gonna put you under the magic box. Oh no! We're losing her! We're losing her!
Get the defibrillator.
Wait a minute, one more time. Okay.
Daisy's saved.
We did it! We did it!
I wanted to make sure that before I stuffed the dinosaur, everything worked. So the arm's moving because of the popsicle stick and everything, and the code. But now when someone passes, it can wave.
Robot Ninja says, when power is provided to a microcontroller, it just starts executing its program right away. You don't have to have it plugged into your computer at all. That's how you can make a standalone device like this.
Okay, yeah, it's working. Okay, I want to hit the button. I just need help getting this in, like without messing it up. I don't know how you got yours in.
I was very delicate.
Thanks, Jackie, for what is it?
Okay, so after you push the distance sensor into the foot and glue it in place, push the popsicle sticks in the dino's arm and the pack with some stuffing around it. Make sure that it still works properly. Yay! Now, challenge 12, the last and final challenge. Sew up your dinosaur. Once you are sure that it works the way you want, are you sure it works the way you want? That sound says yes. Stitch your dino up again. Note the core will come out to plug into the power. Ninja, we need sewing supplies.
Ninja says, sewing supplies are in the room, just not on the table.
I'm so glad I got that Girl Scout badge in sewing. Sewed up the dinosaur. Yay! Surgery went well. And now our dinosaur moves. Robot Ninja achievement unlocked. We are now beginner robot ninjas. Now let's show you guys how our robot dinosaurs work. We got our robot ninja dinosaurs to move with using the motors inside the dinosaur and then the popsicle stick. Now we're gonna call Mr. Ninja so we can come and see what we finished.
Hello, and congratulations. You've done an excellent job building your robot dinosaurs. You are now beginner robot ninjas. Use your powers wisely.
I guess we really are robot ninja masters training. Hi, robot dinos.
Thanks so much for watching. Please subscribe and smash that like button. Funding for this has been provided by the National Science Foundation, which supports science research and education. See you next time.